This last little bit that we need to know on continuity is kind of nice because we basically already know it from limits. So a blank makes the denominator 0 but factors and cancels with the numerator. Which one was that from limits? Was that the vertical asymptote or was that the whole that was factored and canceled? That was the whole. So a whole is what is going to make us discontinuous at first because we can't plug it in. It violates that first property. You can't plug in and get a y value. It gives you an error in your calculator because you divide by 0. But you can factor and cancel and get rid of it. So this is going to look like a hole in the graph. It's removable. It's just this tiny open hole. Okay? And a blank makes the denominator 0 and does not cancel with the numerator. That was the vertical asymptote. That's our infinite discontinuity. We're going up or down, all crazy. Something like that. There's all those different ways to draw a vertical asymptote that we looked at with limits. So we're going to be able to find holes in vertical asymptotes algebraically without ever looking at a picture for a removable or infinite discontinuity. So in order to do this, we're going to figure out what makes us divide by 0 and whether it factors and cancels like a whole would or whether it doesn't cancel like a vertical asymptote would. So we're going to identify the x values where the following are discontinuous and state whether the x values are a whole or vertical asymptote. Again, a whole cancels and a vertical asymptote does not. Does not cancel. And then we're going to also give the interval that it would have been continuous. So be super careful on the homework. Some questions ask where is it discontinuous, and others ask where it's continuous. That's why we're going to do both on all these problems, but the WebAssign homework only asks you one or the other. Where is it always continuous? Where is it discontinuous? So be careful which answer you're entering in. So looking at this first function, we have f of x is x to the 5th plus x squared plus 4. So this is our polynomial function that we talked about. We said polynomials are continuous everywhere. We said it at the bottom of our page before. We said polynomials are continuous everywhere and rational functions are continuous as long as the denominator is not 0. So this is a polynomial. Nothing can make us divide by 0 because there's nothing in the denominator. There is no denominator. Polynomials are always continuous. So now WebAssign would ask two possible things about this. It would say state where it's discontinuous or state where it's continuous. That interval where it's continuous and the interval of continuity can also be abbreviated IOC. Interval of continuity. IOC. So if it asks where it's discontinuous, you could type in none. There's no place where it's discontinuous. There's not going to be an x value that makes you divide by 0. There's no denominator. And for the interval of continuity, how would we write that? You can plug in any x value you want and you will always be continuous. You'll always have a y value. You'll always be able to find a limit and they're always going to be the same number. So any x value ever, how you write that is negative infinity to positive infinity. So two different looking answers that say the exact same thing, so just be super careful whichever one WebAssign is asking you because it differs depending upon which problem you're on. Sometimes it's saying where it's discontinuous, there are no places, but the interval of continuity is everywhere, negative infinity to infinity. So kind of a silly example because it's a polynomial. All right, let's look at something harder. We have g of x is x squared plus 3x minus 10 over 4x plus 20. This is going to be discontinuous where the denominator is 0. So let's figure out what would make the denominator 0. So we're going to do the same steps in all of these. First, we're going to factor the denominator, because that gives us where we're discontinuous. Second, we're going to factor the numerator. And this is super important to not do both at the same time, or else you might confuse yourself, because the denominator gives discontinuities and the numerator gives the type. The denominator tells you where you're going to be discontinuous. It gives you your discontinuities, and the numerator just tells you the type. If it cancels, it's a whole. If it does not cancel, it's a vertical asymptote. So if we look at this denominator first, just factor the denominator. You have 4x plus 20. It's a binomial. I can pull out that 4. 4 times x would be 4x, and 4 times positive 5 would give me positive 20. So what can make this 0 is if they multiply to be 0. So they can only multiply to be 0 as long as one of them is 0. So 4 can never be 0, but what would make x plus 5 equal 0? You can subtract that 5 over. Negative 5 is our only place where we're discontinuous. It's the only x value that would make me divide by 0. So I don't want to factor the numerator right away because that just might confuse me into thinking that my numerator is going to give me a discontinuity when it will not. So x is negative 5 is the only thing that makes me divide by 0. It's my only discontinuity. And I factor the numerator to just see which type. Does it cancel and it's a whole, or does it not cancel so it's a vertical asymptote? Let's factor the numerator and see. We want to reverse FOIL because we have a trinomial. There's no greatest common factor to pull out. We want to multiply to be a negative 10, so I must have a positive times the negative to multiply to be a negative 10. And I want to add up to be a positive 3, so the bigger factor is going to be the positive one because we're adding up to be a positive number. So if we do positive 10 minus 1, that's 9. That doesn't work. What about positive 5 minus 2 is 3. So x plus 5, x minus 2. Give me 3 when I add them and negative 10 when I multiply them. So does my denominator cancel? Yes. It's still a discontinuity because you cannot plug in negative 5 to the original. 4 times negative 5 is negative 20, plus 20 is 0. It fails that first property. You cannot just plug it into the original function. So it's definitely a discontinuity, but because it cancels, it's called a whole. All right, so here's where we're discontinuous. The other thing that WebAssign could ask you is for your interval of continuity. Well, where are you continuous? And when there's a number to exclude like this, I like to draw myself a little bit of like a picture to remind myself what this would be. So I'm continuous everywhere except for negative 5. That's the only place I can't plug in is negative 5. I can plug in any number before negative 5 and I won't divide by 0, and I can plug in any number after. So how do I write this as an interval? Any number before negative 5 would be negative infinity to negative 5. Union, we use union when we're talking about interval notation, any number after negative 5 would be negative 5 up through infinity. There's our interval of continuity. Any number before negative 5 and any number after negative 5. And now you might be asking yourself, wait a minute, what about x's too? That makes the numerator 0. Are discontinuities ever going to come from the numerator though? No. Plug it into your calculator. What if the numerator is 0? What if you have 0 divided by 4? Plug it into your calculator. You get 0. It's okay to have 0 in the numerator, so we're not worried about that. That's why we always factor the denominator first. Don't let the numerator trick you. You do not get discontinuities from the numerator. All right, let's look at another one. So we have h of x is 5x minus 15 over x squared minus 9. So first thing I'm going to do is just factor the denominator. So x squared minus 9, that's a difference of 2 squares. X and 3 are getting squared, so I'm going to write it as x plus 3, x minus 3. And these, either of them could be 0, and they would multiply to be 0. So try to set each of my factors to be 0. Last one, 4 could never be 0, but both of these could be 0. X plus 3 could equal 0, as long as x is negative 3, and you could just subtract that 3 over if you can't see it. And then x minus 3 could equal 0 if x is positive 3. So if WebAssign was asking for where am I discontinuous, I would say negative 3, comma 3. There's the two places I'm discontinuous. And then if it asks the type, then I need to factor the numerator. So we have 5x minus 15, another binomial. This one we have a greatest common factor because they're not square numbers. So I can pull out a 5 times x would give me 5x. And then 5 times negative 3 would give me negative 15. Okay, so do either of our factors cancel? Well, yes, this x minus 3 cancels. It's still a discontinuity, but which type is it called if it cancels? It's called a hole in the graph. Whereas the one that does not cancel is called a vertical asymptote. Holes cancel, vertical asymptotes do not. The final thing that you could be possibly asked about is the interval of continuity. Well, where are you continuous in? Here are the two places where you're discontinuous. Now let's figure out where you're continuous. I think it's helpful to draw yourself a picture or else you might forget a piece of your interval. So I need to say I'm continuous everywhere before negative 3 and everywhere after positive 3. And for some reason, if you don't draw a picture, you might forget about this middle interval here. You can plug in any number in between these numbers as well. Any number except for negative 3 and 3. So we put those on the picture, and then we write this in interval notation. All the numbers before negative 3 are going to be negative infinity to negative 3. Union the numbers in between negative 3 to 3. You are good to plug in without dividing by 0. Even if you plugged in 0 here. 0 squared is 0 minus 9. You're divided by negative 9. Everything's fine. Union, this last piece, would be 3 to infinity. So your discontinuities are negative 3 and 3, and your interval of continuity looks completely different, but it's the same information just written the opposite way. So again, just be careful of what website is asking you. I would encourage you to just pause this video, try the last example, see if you can get it on your own, and then check back with the video. So what I'm going to do is jump in and just look at the denominator, the only place where I can get discontinuities. I'm multiplying to be a negative 28. So I have a positive times a negative. And I need some factors of negative 28 that are going to add up to be 3. So my positive factor is going to be the biggest one. So you would have positive 7 minus 4 would be positive 3 and multiply to be negative 28. Let's set both of these equal to 0. X plus 7 equals 0 if x is negative 7. You can subtract that 7 over if you need to. X minus 4 equals 0 if x is 4. I have two discontinuities. Two places where I'm discontinuous on this graph, negative 7 and positive 4. Now my task is to figure out what types of discontinuities they are. So then I go back and I factor the numerator. Again, I don't factor the numerator right away just because it might trick me into thinking of discontinuities that I don't. So I want to multiply to be a negative 20. So I have a positive times a negative, and I want to add up to be positive 1. So I need factors of 20 that differ by 1. So that's going to be positive 5 minus 4. And now, do either of those factors cancel with the denominator? Yes, the x minus 4 cancels. The one that cancels is always called a hole. The one that does not cancel is called a vertical asymptote. And don't be tricked by the numerator. You never get discontinuities from the numerator. Negative 5 is totally fine to plug into this. You would have 0 divided by 2 is what you would get when you plug into the original. 0 divided by 2 is just 0. So you're good to go. Last thing that WebAssign could ask you is for the interval of continuity instead of asking you for the discontinuities. I'm going to draw a picture. I'm going to put my two important numbers on there. Negative 7 I need to skip over, and positive 4 I need to skip over. I can be any number before, in between, or after. And I want to write that in interval notation. So before negative 7 is negative infinity to negative 7. Union between the two is negative 7 to 4. Union, anything after 4 is going to be in 4 to infinity. And there's our last little bit on continuity.